Okay, so imagine this scenario. You've got, like, potentially groundbreaking medical research just stalled.
Hmm.
Or maybe financial fraud systems that are kind of hobbled, even vital law enforcement stuff.
Hmm.
It just can't move forward.
Right.
And it's not because there's no data. I mean, you've got mountains of it, really valuable stuff, but you can't use it
Yeah.
or share it.
Yeah, exactly. These really strict privacy regulations, things like GDPR, they basically act like this massive wall, all that potential just locked away.
It's so frustrating. You think about the compromises people make.
Yeah.
Either they risk privacy, maybe centralizing sensitive data somewhere they shouldn't,
Which is a huge risk.
or they just cripple their own innovation.
Right.
Using only these tiny sort of anonymized bits of data, it feels like a lose-lose.
It absolutely is. I mean, the need for secure, scalable ways to generate and share data, especially in critical areas like healthcare, finance, law enforcement, it's undeniable. But the current ways people try to do synthetic data generation, SDG, well, they often mean you have to centralize the processing or give someone external access to the raw data.
And that's a non-starter for privacy, right?
Immediately.
Yeah.
Yeah. For anyone dealing with sensitive info, that just raises huge red flags. Data sovereignty, regulatory compliance. You can't just send confidential stuff offsite and cross your fingers.
And that is exactly why this is such a fascinating deep dive today. We are going to unpack frankly, a pretty revolutionary new framework. It's called SynthGuard.
Right.
We found this amazing academic paper from Eduardo Brito and his team, and they introduced this approach. It really promises to redefine how we manage and use sensitive data.
Sounds promising.
Yeah. So get ready, because we're going to explore how data owners can actually keep control over their information, ensure privacy, make it scalable, and stay compliant, all at the same time.
Okay, so let's really get into that pension first. The core problem. On one hand, you've got AI, machine learning, deep learning.
Yeah, all the data-hungry stuff.
Exactly. They absolutely thrive on huge amounts of high-quality data. That's how they learn, how they work. They need feeding.
But then, bam, you slam into these increasingly tough privacy rules. GDPR in the EU is the big one, but there are others.
And they're not just guidelines. They're serious legal barriers. They make getting data really hard, often meaning these super long compliance checks.
Which just grinds innovation to a halt. It really is a catch-22, a big one.
So to try and bridge this gap, we've seen privacy-enhancing technologies, PETs, starting to emerge.
Right, PETs.
And within that whole world of PETs, today we're focusing specifically on synthetic data generation. SDG.
Okay, so maybe for folks who aren't deep in this, what's the key difference? Why is SDG potentially so much better here than, say, just trying to anonymize data the old way?
That's a really important distinction because they sound similar, but they're fundamentally different.
Okay.
With traditional anonymization, you're taking the real data and messing with it. Masking things, scrambling IDs, removing names.
Trying to hide who's who.
Exactly. But even with really good techniques, there's often still a risk that someone could re-identify individuals, put the pieces back together.
Right.
With SDG, it's totally different. You're creating entirely new artificial data points.
Ah, so it's not the original data modified.
Not at all. It's brand new data. But, and this is the key, it's designed to closely match the statistical properties, the patterns, the relationships found in the original real data.
So it looks like the real data, statistically speaking.
Precisely. Think of it like a really high-fidelity statistical replica, but without any of the original fingerprints or personal details. Because it's not the actual source data, the privacy guarantees are just much, much stronger.
Okay, that makes sense. But here's something in the paper that really jumped out at me. Most of the research effort, it seems, has been on, making the generation better, the algorithm.
Yeah, improving the quality, the realism.
Or on evaluating it, checking its utility, its privacy levels, which is all important, obviously.
Right.
But the paper argues that the real challenge, the one that often gets missed, isn't just what you generate, but how you actually practically generate it, the operational side.
Yes, exactly that. It's about implementing SDG workflows that are secure, that can scale, that are adaptable, while keeping that crucial data sovereignty, making sure the data owner stays in control, and, of course, keeping up with all the legal standards.
So it's like the plumbing matters just as much as the fancy faucet.
That's a great way to put it.
Yeah.
Making sure the whole process, end to end, is trustworthy and compliant. And that's the core issue this deep dive is tackling, the one SynthGuard aims to solve. How do you let data owners keep control, meet regulations, but also have systems that are modular, easy to combine, transparent, auditable, reliable, across all sorts of different environments.
So SynthGuard is positioned as the answer. What's the core idea then? How does it rethink things?
Okay, so at its heart, SynthGuard is about weaving governance, scalability, and compliance right into the SDG workflow itself. It's not an add-on.
Integrated from the start.
Right. And what's really interesting is this focus on computational governance. That's a key term they use.
Computational governance. And what does that mean in practice?
It means that the sensitive, real data and the computations being done on it, they stay securely under the data owner's control, physically, logically within their boundary.
Ah, so it prevents that off-premises exposure we talked about. The raw data never leaves home.
Exactly. It's not just about encrypting data while it travels, it's fundamentally shifting the paradigm. Instead of data has to move to the computation,
Its computation has to come to the data. Is that the big shift?
that's the absolute core principle. You've nailed it. Think of it like instead of sending your secret family recipe out to a factory,
Right.
you bring a certified mobile synthetic recipe generator into your own secure kitchen. It does the work there under your supervision, produces the synthetic version, but your original secret recipe never leaves the kitchen.
I like that. Okay.
And this ties directly into ideas like data sovereignty and domain ownership. It means setting clear rules. What data is it? Where does it live? Where does it get processed? And who gets to do it? It's kind of like a data mesh approach, decentralized, controlled management, instead of forcing everything into one big, potentially leaky, central pot.
That makes a lot of sense, especially for sensitive sectors. So architecturally, how does SynthGuard actually guarantee this? How does it work?
Well, the absolute foundation, as we've said, is that the real data stays put within the data owner's domain, full stop.
Non-negotiable.
Totally. This is critical for meeting privacy rules, compliance mandates. It's requirement number one. Secure generation without sending data out. Privacy baked in from the start.
Okay. And you mentioned flexibility. The paper talks about modular and composable SDG workflow design. Sounds fancy, but what does it let you do?
Think of it like building with high-tech Lego bricks. Seriously. SynthGuard lets you pick and choose different software components.
Like different SDG algorithms.
Exactly. Maybe Python libraries for one task, R libraries for another. You can select them, configure them, and basically snap them together to build these tailored data pipelines.
So you can customize it for specific needs. Different data types, maybe.
Precisely. Or specific regulatory hurdles you need to clear. You don't have to build everything from scratch each time. It makes developing and deploying these things much faster, much more adaptable, like building blocks for data synthesis.
Okay, but that raises a key question. If the real data never leaves the owner, how do they collaborate with, say, researchers or analysts who need the synthetic data? What's the secure handshake? How do they agree on what's being done?
Good question. That's where this thing called the standardized SDG pipeline specification comes in. It's central.
The pipeline specification. So it's not the data itself.
No. Think of it as the blueprint. It's a declarative artifact, basically, a detailed plan. It spells out all the tasks in the workflow, the software needed, the settings, even the code for each step of generating the synthetic data. The data consumer, like the researcher, might propose this blueprint. But the data owner gets to review it, check it against their policies, approve it, before it ever gets run against their sensitive data.
I see. So the owner approves the method, the how-to, not the raw data itself. That's clever. That's the trust mechanism.
Exactly. It enables collaboration without ever exposing the raw, sensitive stuff. It's a huge step.
Okay, technically then, how does SynthGuard pull all this off? What's running under the hood to manage the complexity, make it reproducible, make it scale?
So for making sure things are consistent and run anywhere, reproducibility and portability, it uses tools like Docker for containerization.
Right, packaging things up.
Yeah, putting everything needed, the code, the libraries, the settings into a neat little container. And also Nix, which is really good for ensuring reproducible software environments.
So Docker and Nix are like
Yeah,
creating a perfect identical recipe box every time.
that's a perfect analogy. It guarantees that the exact steps, the software versions, the whole environment used to create that synthetic data are identical, whether you run it today or next year on your server or in the cloud. That's absolutely vital for audits, for trust, especially in regulated fields.
Like ensuring a scientific experiment can be perfectly replicated.
Precisely that level of rigor. And then to actually run these potentially complex workflows, especially when you scale up, they use Kubernetes.
Ah, the orchestrator.
Yep. Specifically Minikube for like local testing or smaller setups. and kubeflow pipelines for the heavy lifting. Imagine trying to conduct a huge orchestra, right?
Okay.
Kubeflow is like the conductor. It makes sure all the different parts of the data loading, the processing, the generation, the evaluation run in the right order in parallel where possible, scaling resources up or down as needed. It automates the whole thing based on that blueprint, that specification we talked about, even across different clouds. It's called declarative orchestration.
Okay, so it handles the complexity automatically. And I think I saw something about even more security layers, trusted execution environments, Ts.
Yeah, that's pretty cutting edge stuff. So imagine you have to run some computation in an environment you don't fully control, like a public cloud.
Which happens a lot.
Right. Ts are like these super secure, isolated hardware enclaves within the server. Think of them as tiny, tamper-proof black boxes.
Inside the main computer.
Exactly. SynthGuard is designed so it can use these Ts for the most sensitive parts of the computation. It means that even the cloud provider or other software on that machine physically can't peek inside or mess with the data while it's being processed in the T.
Wow, okay, that's another serious layer of protection.
It really is. It's for those ultra-sensitive scenarios. And just to cover the bases, SynthGuard isn't just for one type of synthetic data. It can handle different categories depending on what you need.
Oh, like what?
Well, there's realistic synthetic data, RSD, which is focused on replicating the statistical properties really well. Then causal synthetic data, CSD, which tries to preserve the cause and effect relationships in the data, super important for some types of analysis.
Okay.
There's also artificial synthetic data, ASD, which might be generated just from aggregate statistics, not even needing row-level access sometimes. And hybrid approaches, HSD, that mix these things. Different problems need different solutions, different types of synthetic data.
It sounds incredibly thorough, really well thought out.
Yeah.
But theory is one thing. Did they actually, try this out in the real world? Did SynthGuard get put through its paces?
Oh, absolutely. That's one of the strong points of the paper. This wasn't just cooked up in a lab and left there.
Good.
It was developed and tested iteratively within 2 big Horizon Europe research projects, real-world stuff. One was called LEGO that focused specifically on sharing data between law enforcement agencies, which is obviously super sensitive.
Hugely sensitive, yeah.
Yeah. And the other was TADLE, which was incredibly broad. It covered domains like evidence-based medicine, financial governance, even smart farming, viticulture, mobility data, regional planning, just a whole range of applications.
Wow. Okay, so diverse use cases.
Exactly. And these projects brought out very specific, tough requirements that SynthGuard had to meet. Things like, absolutely ensuring the data owner keeps control, that they validate the output before anything gets shared.
That we've been talking about.
Right. And also providing workflows that were genuinely scalable and modular enough for these different real-world needs. So yeah, definitely not just an academic exercise. It was built to solve actual problems people were facing.
That real-world validation is so important.
Yep.
Okay, so how did it actually perform, especially on the scalability front? Could it handle those mountains of data we started with?
They did some practical benchmarking. They used real anonymized law enforcement data sets of different sizes. Started with 1,000 rows, then 10,000, then up to 100,000 rows.
Okay, decent sizes.
Yeah, and they ran it all on a pretty standard cloud virtual machine, nothing too exotic. The results were actually really impressive.
How so?
The total time it took scaled really well. For the 1K dataset, it was just 1.6 minutes. For 10K, about 5.1 minutes.
Wow.
And even for the 100K dataset, it was still only around 16 minutes total runtime.
16 minutes. For generating synthetic data, including all the checks from 100,000 records, that's actually surprisingly quick.
It is, especially when you think about how long manual processes or less optimized systems could take.
Right. This goes straight back to that core problem we discussed. Innovation slowing down.
Yeah.
If you can do this kind of privacy-preserving generation efficiently, scalably, that suddenly unlocks projects that were maybe impossible before or just too slow.
Exactly. It enables that faster cycle development for AI, for research that data access restrictions often block.
Were there any parts that took longer as the data grew? Any, bottlenecks?
Well, what was interesting, and this shows the thoroughness, is that for the largest data set, the 100K one, the steps for evaluating privacy and checking the utility, the quality, those actually accounted for over 90% of that 16-minute runtime.
Ah, so the checks are the most intensive part.
At scale, yes. But here's the clever part. Because SynthGuard's design is modular, and because tools like kubeflow can run tasks in parallel,
Like the orchestra conductor again.
Exactly. Those evaluation steps didn't just stack up one after the other, making the total time explode. They could run concurrently, alongside other parts of the process where possible. So the design itself helped mitigate those potential bottlenecks. It's like having multiple quality control teams working at the same time, rather than one long sequential line.
So it's not just fast, but it's built to stay relatively fast even when doing the really important, intensive checks. It's like built-in quality control and privacy auditing that doesn't cripple the speed.
That's a great way to summarize it. And this ties into the trust aspect.
How so?
Because SynthGuard isn't just generating data and hoping for the best. It integrates these rigorous checks for privacy and utility directly into the pipeline. It's not an afterthought you run later. It's part of the process, ensuring trust by design.
Okay.
They use specific metrics. For utility, something called PMSE propensity score mean squared error, which basically checks how well the synthetic data captures the predictive relationships in the original data. Is it actually useful?
Right. Does it behave like the real thing?
Yeah. And for privacy, they use methods like categorical DICP or neurosynthesis. These are designed to assess the risk. Could someone potentially re-identify an individual record, even accidentally, from the synthetic data?
So you get actual metrics telling you how safe and how useful the output is.
Yes, before it ever gets shared or used. That provides real confidence. You know the data is useful and safe.
Okay, let's zoom out then, connecting this back to the big picture.
Yeah.
Why does SynthGuard matter to, someone listening right now? What's the real so what beyond the cool tech?
Well, I think SynthGuard offers a genuinely balanced, practical path forward. It tackles that privacy utility dilemma head on. It basically empowers organizations, especially in those really sensitive fields, healthcare, finance, public sector, to actually use their data, to innovate, to build better services without having to compromise on trust or fall foul of regulations.
And it unlocks the potential we talked about at the start.
It really does. It helps unlock data's value while still respecting fundamental rights and legal rules. It's finding that workable middle ground.
And it feels like this isn't just about one company solving its own internal problem.
Mm-hmm.
You mentioned collaboration. Could this framework enable something bigger?
I think it definitely lays the groundwork. You could imagine a future built on these principles where synthetic data markets could actually become a reality.
Synthetic data markets, what would that look like?
Well, imagine secure, audible, controlled ways to share insights derived from data across different companies, different sectors, maybe even across national borders, all using high-quality synthetic data generated under the owner's control via frameworks like SynthGuard.
Wow.
It could foster collaboration on a scale we haven't seen before, precisely because you'd have mechanisms to manage the privacy risks and maintain control. Fewer legal headaches, fewer privacy roadblocks.
That's a really exciting prospect.
Yeah.
Okay, so just to quickly recap, we've unpacked SynthGuard today. It's this really innovative framework designed to get us past that privacy paradox with sensitive data. It lets data be generated synthetically, shared, and used securely, scalably, and crucially, always under the original data owner's control.
It really feels like a potential game changer for data governance and how we approach innovation with sensitive information. It redefines what might be possible.
Absolutely. So that leaves us with a final thought, something for you to mull over. If frameworks like SynthGuard can genuinely guarantee privacy and maintain control during sensitive data generation, what does that mean for the future? What are the next big frontiers for synthetic data? Could we start seeing maybe real-time synthetic data generation becoming common? Or perhaps integrating these principles into huge interconnected data ecosystems that finally manage to balance global innovation with respecting individual privacy? Where could this take us next?